1, 2, 3, 4, 5 and 6. Okay, I push those down. I put grease in those holes first, so there's no way that those pins are going to fall out. The grease just holds them steady. Now what we've effectively got now on the end of the tool is a blank key. We've got the lever lifter or the bolt thrower in the centre, and we've got the 6 lever lifters at the maximum height that they can be. And really all that a pin and cam system is a mechanical impressioning tool. If you were to impression a lever lock, you would take a blank key, place it into the lock, apply torque, which would drive the racking stump against the sides of the levers, and some of those levers would bind up because they're at the wrong height. You would then move the key relative to the levers whilst that pressure was still being applied, and the levers that were in the wrong position would mark the surface of the key. You would then file them down to the next height and repeat the procedure. In actual reality, it's quite difficult to impression a lever lock because the surface of the key is so wide. So what people tend to do is file them to be nice and sharp, so that the amount of material that's in contact with the lever is only the knife edge, and then it's much easier to get a marking. Of course, the procedure is quite difficult to do. It does require a lot of pressure to hold them. It's difficult to get a lot of movement, and what tends to happen is the keys tend to break, you make mistakes, it's difficult to interpret the marks, and so on and so forth. Not so with the pin and cam system, but we are trying to do the same thing. Basically, when I push the button under any given pin, it forces that pin to lift. In this particular case, the first pin, the one nearest to me, as I press the button, is being lifted because the ball underneath is being raised by the push button. If I then click to the next position, I can raise the second pin. The amount of lift we get is about 0.5 millimeters. That's all that's happening. It's lifting the pin 0.5 millimeters. Now if I put the tool into the lock and I then apply a turning force to the lock, the same thing that will be happening when you impression it is happening inside the lock right now. The racking stump is being driven in against the sides of the levers, and when I press this button, the ball bearing lifts the pin, and if the lever on top of that pin is not under pressure, is not being bound up by the turning force, the ball will go up very easily. And as you can see there, it's very easy to press the push button in. Now if I click to the next position and apply force again, we find the same thing. It's a gentle turning force. In fact, it's just occurred to me that I've done a completely wrong thing. Just put it in the other way up. I've got the tool in the wrong way round. Don't worry about that. Okay, it needs to be in this way round. The levers are on the other side of the lock, so I've just turned the lock round to get the levers in the correct position. Okay, we'll go back to position number 1. Okay, now, button number 1 is loose. Okay, we go to the next position, but in position 2 it's not easy to push in the button. It's tight, and it's tight because the lever that's sitting on top of that pin doesn't want to move. It doesn't want to move because the racking stump is pushing against it, and the only reason why the racking stump would be pushing against it is because it's at the wrong height. So what that's telling me is that pin number 2 is not correct. I'll progress a little bit further and do number 3. 3 is loose, 4 is loose, 5 is rigid, and 6 is loose. So pins 2 and 5 are wrong, therefore pins 2 and 5 need to be changed for shorter pins. Now what I've done now is put those shorter pins in, and you can see that the shape of the key now has changed, and the second pin is the height of the next known lift down. So what I've effectively done here is, if you relate it to impressioning again, it's just like getting 2 markings and filing those cuts down to the next height. So that procedure is then repeated, and in each case all you do is you go to all 6 levers and test to see which ones are rigid, and 2 is rigid again, 3 is loose, 4 is loose, 5 is rigid again, and 6 has got a little bit on it, but it's basically 2 and 5 yet again. So I change 2, and each time I'm changing a pin, I'm simply changing it for the next pin down from what it is. If I make a mistake with this system, it's no problem. I can always put the larger pin back in again and go round a second time. Now there's resistance on 1, 2, 3 is fine, 4 is fine, 5 is fine. 1, 2 and 6. All 3 of those pins need to be changed. 1 goes down to a 2. 2 goes from a 3 to a 4. And 6 goes down from a 1 to a 2. In reality, it doesn't take very much time at all to form the shape of the key. 1 is absolutely rock solid. I can't even press the button in. 2 is now fine. 3 is now binding. So it's 1, 3. Just 1 and 3 need to be changed. Right. 1 is under resistance. 2 is resisting. 3 is fine. 4 is resisting. 5 is resisting. Right, so that's 1, 2. Just check that again. 1, 2, 4, and 5. And that's it. Okay, so what we now have is the code for the first part of the key. On the majority of European lever locks, that would be sufficient for you to go away and make a full key that would open up the whole lock, because the majority of locks have got some kind of relationship between the levers on one side and the other side of the key. They're either cross-reference, as I said, this one matching this one matching this one, or they are relative on the same side. Where this is low, the other side is proportionally higher. So the distance from one side to the key to the other is always exactly the same. That's effectively what I'm saying there. Majority of them are like that. This particular lock is an exception to that rule. There is no relationship between the size of the lever lifters on one side to the side on the other. So on this particular case, I've modified the pin and cam system. What I do now is I pull this back, rotate it 180 degrees and slide it forward, and now the ball bearing jumps to the other side of the key, and I would put in 6 number 1 cups on this side, put the tool in, turn the lock, and then carry on working on the other side until that side was correct, and then obviously I'd have both sides and I could just use the tool to open up the lock. But that's more of an exception than anything else. In Britain, the keys only turn once anyway, so there's only a requirement to open the lock once, and then you've got the entire lock open and you can open up the door. There's none of this 3 or 4 rotations to actually open the door. So that is effectively what a pin and cam system is. It doesn't make any difference whatsoever if there are false notches on the levers. It makes no difference at all if there's a barrel and curtain. As long as the tool can enter the barrel and curtain and turn with it, it will work. The tool was designed initially for the Chubb 110, which is the most common common British high security lever lock. I've then done others for 114s, leg blacks and various other English locks, and in Europe I do over 60 different systems for all of the locks that are common in those territories. We also make several of them for safe locks. The safe locks do tend to take a little bit longer